a parabola and combine it with what we know about where the roots are to solve a quadratic by graphing. So let's get started with this first one. It is already in standard quadratic equation form. All of my information is on one side and it's set equal to 0. This says that we're going to graph the function like down here, but we're going to be intentional about finding where my y values, my y coordinates are 0. So let's get started. Our a, b, and c, just like before, 1 for a, -3 for b, -4 for c. This graph is going to open up because a is greater than 0, which means that my vertex is going to be a minimum. Right? If it opens up, then my vertex is my smallest, so we're going to have a minimum. My y-intercept is always 0, c, and in this case it's going to be 0, -4. My axis of symmetry, which also gives me the x-coordinate of my vertex, right here, is the opposite of b, or negative b. So the negative of -3 is 3 over 2 times a. A is 1, so that's 3/2. And I'm going to plug it in to the function. All right, disregard the 0 on this part because we want to find the y value. So 3/2 squared minus 3 times 3/2 minus 4. That's going to give me 9/4. This is -9/2, which is also -18/4. And then -4 is -16/4. And so I get -25/4. So my ordered pair is 3/2 -25/4, which if you need it in decimal to understand where you are on the graph, that's -6 1/4. So I'm going to draw in my axis of symmetry here at 1.5, that's 3/2. I'm going to mark my vertex at 3/2 -6 1/4. 1, 2, 3, 4, 5, 6 1/4, right about here. Okay. That's my vertex. My domain is going to be -infinity to +infinity. My range, this opens up. So that means that my y value here is the smallest y value, and everything else is going to be bigger. So it's going to go off to +infinity. Then I'm going to fill in my table. I start by putting in my vertex. And then I'm going to use my y-intercept. And I'm going to label it y-intercept because I've already calculated it. So here's 0, -4 right here. 1, 2, 3, 4. So here's 0, -4. Then I'm going to use symmetry to find my other side. So this is 1.5 left, so I'm going to go 1.5 right. 1/2, 1.5, and that is the point 3. -4. And then I'm going to plug in a -1. That's this one over here. And I get y equals -1 squared is 1. -3 times -1 is +3 minus 4. So that gives me -1, 0. All right, so let's highlight this because this is an important point because this is kind of what we're looking for. We look for a y coordinate of 0. And now let's plot it and use symmetry to find the other one. This is 1 space, 2 spaces, 2.5 spaces left. So now I'm going to count 2.5 spaces right. That's 1/2, 1, 2. So it's right here, and that is the point 4, 0. And I'm just going to write symmetry. Now I'm going to connect all of my points. and label my solutions as negative 1, 0. Roots, solutions, the same thing, and 4, 0, 4, 0. Right? The next one, we notice that it's conspicuously not in standard form, so I'm going to move my negative 8 over, and I'm going to move my 11 over, and that gives me x squared plus 8x plus 16 equals 0. All right, now the rest of the graph, what I'm going to do is I'm going to treat it like it's just like a function, right? So a is 1, B is 8, C is 16. Notice that our y-intercept is going to be really high, so I have used units of 2 on my coordinate plane. This is going to open up because A is positive, which means that I have my vertex is a minimum. My y-intercept is 0, C, which is 0, 16. So that's way up here. My axis of symmetry is found by calculating the x-coordinate of my vertex, and so I get negative 8, the opposite of positive 8, over 2 times 1, so that's 2, so I get negative 4. Now I'm going to plug it into this version of my function. So I get 4 squared plus 8, oops, that's negative 4 squared. Oh, let me erase that. Start again. Negative 4 squared plus 8 times negative 4 plus 16. And when I calculate that out, this gives me 16 minus 32 plus 16. So that gives me 0. Won't always be, but in this case it is. So this says that my solution is also my vertex. I know that because my y-coordinate is 0. So here is my axis of symmetry. Here is my x-coordinate of my vertex. My domain is going to be negative infinity to positive infinity. My range is going to be from 0 to positive infinity because it opens up, so this has to be my smallest y value. I'm going to put in my vertex. Which is negative 4, 0. I'm going to put in my y-intercept, which is 0, 16, and then I'm going to use symmetry. So this is 4 spaces. It's 4 value. It's like 2 spaces, 1, 2, and so then I have to count 2 more spaces. 1, 2. So here's my other point, and this is negative 6, negative 8. So I get negative 8, 16 by symmetry. Right, and then I graph it. And my solution is negative 4, 0 by inspection of the graph and by identifying it, the y-coordinate being 0. The last one that we're going to do together is we have to write in standard form. So this is negative x squared plus 4x minus 1 equals 0. Now I identify A as negative 1, B as 4, C as negative 1. It's going to open down because A is less than 0 or negative, which means that my vertex is going to be a maximum. My y-intercept is 0, C. Which is 0, negative 1. My axis of symmetry, the x-coordinate of my vertex, is found by the opposite of b over 2a, so I get negative 4 over negative 2, which gives me positive 2. Now I'm going to plug that into the function, and I get the opposite of 2 squared plus 4 times 2 minus 1. This is negative 4 plus 8 minus 1, and my ordered pair for my vertex is 2, 3. So here's my axis of symmetry. My vertex is 2, 3. That's this point right here. My domain is negative infinity to positive infinity. My range, now watch, because this graph is going to open down, that means my y-coordinate has to be the highest point on my graph. So it's going to go from negative infinity to 3. And then we're going to do some plugging in. So at 2, I have my vertex, 2, 3. At 0, I have my y-intercept. That's going to be 0, negative 1. That's here. I'm going to count for symmetry. Notice that this is 2 spaces left, so now I'm going to count 2 spaces right, and that gives me the point 4, negative 1. Right, and then I'm going to fill in between here because somehow I got to see where this crosses. I need the consecutive integers, so I'm going to plug in a 1, and that gives me y equals negative 1 plus 4 minus 1, so that gives me 2, 0, 2, and symmetry is going to give me 3, 2. So here and here, and then we trace these, and notice that I don't have pretty little integers, but I have solutions between. So BTWN, that's for between, 0, whoops, that should be a 1 there, not a 0, between 1 and 2, sorry, I don't know what I'm talking about. I do, but I just said it wrong. 0 and 1, and then again between 3 and 4. And 3 and 4. You can tell here, and you can also tell here. Remember how when we did a table, we go from negative to positive, that means it had to cross through 0. We go from positive to negative, that means it had to cross through 0. All right, that's it. We're going to work on several problems tomorrow. Most of these are going to be looking at the graph and the graph that's already done, and a few of them are graphing. We'll do the whole thing together. All right, so thanks for listening. I'll see you tomorrow.